Hey, what's going on, everyone? It's Justin Dickmeyer from EngineerInTrainingMA.com, and in today's quick tutorial we're going to review permutations. Permutations are an offshoot of the fundamental counting principle, which I covered in a previous quick review. Permutations specifically count the number of ways a task can be arranged or ordered. So first, to start this tutorial review, we got to review what is a factorial. Factorial, written as n or any number exclamation point, that's n factorial. And n factorial is the product of whatever n is, n times n minus 1 times n minus 2 all the way down to 1. So let's say you want to get 7 factorial. It would first be written as 7 factorial. And say you want the product or what that equals. The answer to that would be 7 times 6 times 5 times 4 all the way down to 1. And so the answer to that, if you just put that into your calculators real quick, would be 5,040. So real quick before we go on, factorials are pretty basic, and I know you guys all know them, but I just wanted to touch on those real quick. But one special definition of factorial is we need to know that 0 factorial is always equal to 1. So if in future problems we see 0 factorial, it's not that we're dividing by 0. That actually is equal to 1. So moving on. What is a permutation? Now, a permutation is an order of arrangements of R objects without repetition selected from n distinct objects is called a permutation of n objects taken R at a time. And that is denoted as n p R is equal to n factorial divided by n minus r factorial. So let's define that again. An order, and that's important, so make sure you underline that. An order of arrangements, sorry, running out of room here. An order of arrangements of R objects selected or taken from n distinct objects is called a permutation of n objects taken R at a time. So that might look a little confusing, but in equation form you can just note that the permutation of n objects taken R at a time is equal to n factorial divided by n minus R factorial. So to simplify my complicated definition here that might have confused you guys, sorry about that, but to simplify, when you need to count the number of ways you can arrange items where order, I bring that up again, where order is important, then you can use permutations to count. So once again, when you need to count the number of ways you can arrange items where order is important, then you can use permutations to count. So let's look at, let's illustrate this using an example here. So let's say that we have 8 pictures and we want to hang all 8 of those pictures onto the wall. So the question would be, in how many ways can 8 pictures be hung on the wall. So since we are arranging these pictures on the wall, that means order is important. And because order is important, we can use permutations to count how many ways. So first we need to define the number of objects or pictures. And so n, like I said, is the pictures in this example. So since there's 8 pictures, n is going to equal 8. Now R, on the other hand, is the number of pictures we are going to use at a time. So once again, we want to hang all 8 pictures on the wall. So all 8 pictures are going to be used at the same time. So R is going to equal 8. So taking our permutations equation that we defined before, we got n factorial divided by n minus r factorial. And all we need to do is plug in our numbers or our values for this specific problem. So we have 8 objects, so n is going to equal 8, and we want to hang all 8 of them on the wall at the same time, so r equals 8. So we can simplify that as 8 over 0 factorial, and once again I said 0 factorial is equal to 1. So we can go ahead and just simplify this as 8 times 7 times 6 times 5 times 4 all the way down to 1. And when we multiply that all out, we find that it's 40,320. So that's a very large number, and that tells us that there's 40,320 ways that 8 pictures can be hung on the wall all at the same time. So let's move on to another example. Let's say that we have an engineering group, and that engineering group has 20 members. And out of those 20 members, that engineering group needs to select a president, it needs to select a vice president, and it needs to select a speaker. And assuming that the same person cannot hold that two positions at the same time, assuming that a member can hold only one position at a time, that's our assumption. So one member can't be vice president and president. So we can move forward and define our values n and r. And once again, since we are choosing positions, this is a way to rank members, and rank equals order. So order is important in this problem once again, so we can use the equations of permutations to determine the number of ways that 3 members can be chosen from the 20 within the group. So we first need to define n. So n is the number of members we can choose from, and in this case we have 20 members. Of those 20 members, we want to choose 3 for this, the positions: the president, the vice president, and the speaker. So since we're choosing 3 at a time, r is going to equal 3. So once again, all we need to do is take our standard permutation equation. We got NPR is equal to n factorial divided by n minus r factorial. And we know that n is equal to 20. And we know that r is equal to 3. So to simplify that, we got 20 factorial over 17 factorial. Now let's just say most of us are going to be using the factorial key on our calculators to determine what these equations are equaling out to be. But let's just say you don't have that, just for conversation's sake here. You can simplify this equation so you don't have to write it out as 20 times 19 times 18 times 17, etc. And since I already wrote it out like that, let me show you how you can simplify it. So let's expand on 20 factorial. That's 20 times 19 times 18 times 17 times 16 all the way down to 1. 17 factorial is 17 times 16 times 15 times all the way down to 1. Now all we need to notice here is that we can cancel out every value from the denominator that's on the numerator, starting at 17 all the way down. So our answer here will really be 20 times 19 times 18. And in this case, that equals 6840. So running the calculations, this tells us that there are 6,840 different ways to select 3 members of the 20-member group for the 3 positions. So that's it, guys. That's all there is to permutations. I know it might sound a bit complicated, just the word in itself, but it's really all not that big of a deal. Once again, we're concerned with order in these problems. So let me just tell you once again that the definition is an order of arrangements of R objects without repetition selected from n distinct objects is called a permutation. So that's it. If you guys have any more questions or need any more guidance for preparing for the engineering training exam, don't hesitate to visit my site at EngineerInTrainingMA.com, and I look forward to meeting you guys and helping you in any way that I'm able. So for now, take care.